Hello and welcome to the 8th video in this series, making simple Flappy Robin for the iPhone and iPad using Cocos2d. So in this video then, we're going to set about actually, now that we've got the Robin jumping in the application, we need to set some objects that scroll across the screen so it actually looks like it's jumping. Now I've already added into the resources and you'll have in the download, I've added a mount PNG, which is the mountain. I've added the cloud in there. I can't remember whether that was already included in a previous download or not. And the tree is in there as well. And these are the objects which are going to be scrolled across the screen to give the impression that the robin is flying. So to do that, what we're going to do is we're going to subclass CC Sprite, and I'm going to call this class, I could call it scrolling object or something like this, but I'm actually going to call it a C Cloud class. I'm just going to do new file, as you've seen before, Objective-C class, make sure that it's subclassed, subclass is CC Sprite, so that we've got all the stuff we need from a sprite. I've called it C Cloud. And then just going to create it and add it to the project. And into the header section, we'll deal with that as usual first. I want to change this import here to actually import Cocos2d.h because we'll be needing a couple of things from there. And what we'll do is we'll do everything, as I've said in the previous video, the sort of lazy way, and we'll do everything via properties. So some properties that we need to know then for our objects that scroll across the screen. We need the speed that they're going to be scrolling across the screen, and you'll see how the whoops, a little bit ring rusty because it's been a couple of weeks since I've done a video. My goodness, very ring rusty. We need the speed, and you'll see how the speed works going across the screen. It's basically in pixels and is per second, and is worked basis of the Y, of course, because our scaling is in the Y direction for each of the devices, and we want, it doesn't matter how wide the device is, we just want the speed that everything appears to be moving across the screen to be the same whether it's on the iPad or the iPhone, so we have to take our Y into account. We want something called an X offset, and the X offset is simply when something scrolls across the screen from left to right, we need to make sure that it's gone completely off the screen before it's on the left hand side before it's reset to the right hand side. So its action to actually move across the screen will be set to go to an X of 0 and then minus the X offset. So we make sure it goes all the way off the screen before being reset to the other side. And the last thing we need to tell it is the screen width as well, so it knows how wide the screen is, so it can set up its action okay to move across the entire screen. You'll see how these properties are set up in a minute when we write the initialization. So we need to add some functions. We need a start function, which will be called when the game starts, everything starts scrolling. Likewise, we need a stop function, which simply will stop all of the scrolling action working on the object. We're going to make a function called reached destination. Now I'm making this function visible, so public in this way, because we'll probably be subclassing this class when we come to actually implement the tubes. The tubes do essentially the same thing but have some more information and properties. So we'll put reach destination here. This is called when they reach their destination going off the left hand side of the screen, so they're simply reset to the right hand side of the screen and set moving again. And last but not least, we'll make an initialize function, and we'll say initialize with speed, so the speed that we want this item to have, so we'll call that speed, and width, and this of course is then the screen width that comes in, so I'll just call this WTH, like so. So that's sort of the setup then for our C Cloud class in terms of the header. Moving on then into the implementation, so the .m file then. I just drop these functions in here so that we can drop in some brackets and then fill this stuff out. And I'm going through this relatively quickly because I don't think any of this is particularly difficult. So we'll start then with the easier stuff before we go into the start. So what we want to do in the stop section is say self and stop all actions. That's all we actually need to do here. And then in the initialization section here, we'll just set up our properties. So we'll say our self.speed is equal to the speed that we've been given. We'll say that self.screenWidth is equal to the WTH. And then last but not least, we want the X offset to be equal to the self.theboundingbox.size.width, so that we wait till we've gone a full width off before we then reset to the other side. So let's now go to the most important part, which is the start, when we set things then actually scrolling. Well, the first thing we're going to do is make absolutely sure there are no actions running on our sprite. And now what we'll do is we'll do this step by step. So we'll take a current X to find out where the object currently is in terms of the X, so self.position X, and the distance that we're going to travel is going to be set up in this distance variable float here, and the distance will be our current X minus, and then it'll be the minus of our self.offset X. Sorry, X offset. So what that'll be is where we're travelling to, remember, is an X of 0, so the left-hand side, but we want to go also our width further than the left-hand side, which is our X offset, which we set down here. So we want actually our total distance would be our X position. So if we were at, say, an X of 100, we would be going 100 to go to the left-hand edge, but then we want to add on for the distance we're travelling also our X offset. So the double minus here essentially then obviously creates a plus. In fact, I'll put this minus inside the bracket here so it's a little bit clearer, like so. So that's the distance then that we want to travel, and now the important bit is to get our time. So the time that we're going to travel, and this is where the speed comes in, will be then the distance divided by our speed. And then this speed here then is scaled according to the Y, depending on whether we're using an iPhone or iPad, and this means then that independent of the device we're doing, the speed that the things scroll across the screen then is the same, or the time that they've been allocated is then the same relative to each other, so the difficulty of the game is the same for both devices. And last but not least, we want to set up our destination point. So I'll call this destination, like so, and this is then simply equal to a CCP, and it's minus self dot X offset, and then the Y of course remains exactly the same. So we have all the information now that we need to be able to, I haven't spelled destination correctly there, but to move our sprite, be it a cloud, a tree or a mountain, from one side, from its current position to being off the left hand side of the screen. So what we need to do then is we need to call two actions on this sprite. One of them is the move action, where we'll move from the current position to the destination, taking time seconds. And then we need another action to call this reach destination function when we've actually reached our destination point. So the first action then is called a CC action move to, and I'll call this action move. And actions in Cocos2d for iPhone 3 are slightly different to how they work inside the previous versions of Cocos2d. We would set up an ID here, but this is Cocos 3, so this is how you do it. So we want a CC action move to, and then we want an action with duration. So we've got the time, and the position we're going to then is our destination. And the next action we need then is a CC action call function, and we'll call this action move done, like so. And much in the same way, CC action call function, and then we want action with target. Well, the target is the self, and the selector then we say at selector, and we want reached destination, like so. So the first action then moves with time seconds to our destination, always with the same speed, using our speed that the sprite has been initialized with, and then when that action move is finished, then we want the reach destination function to be called. And essentially what happens in that is we reset the sprite to the right hand side of the screen and call start again. So the last thing we need to do then is actually run this action, and it's quite simple. We just say self run action, And then because we've got more than one, we need to run something called a CC action sequence. So that's action sequence. And then action with array. So we supply an NS array inside here, like so. And we need simply to give our two actions. We have our action move and our action move done. And that's all we actually need to do to set our sprite moving. I'll just copy and paste that in here and wonder why it's giving me a line like so. I've forgotten the @ here, haven't I? Okay, good. Still in C++ mode as always. So that then will set our sprite moving until it's gone off the left-hand side of the screen, or stop is called at some other point to stop it still. Assuming it reaches the left-hand side of the screen or goes off, then it has reached its destination. So when it reaches its destination, what we need to do is we need to call self, and then we need to now set the new position off to the right-hand side of the screen. And that means saying that we want to set it to self.screenWidth and then plus the self.x offset. So it's going to the right-hand edge of the screen plus its own width. And then we'll keep the Y exactly the same as it was in initialization. And then last but not least, all we need to do is call self and start. And that starts the whole thing going again. So pretty simple stuff. Key things in the start here, just sets it moving from wherever it is based on a set speed off to the left-hand side of the screen, and then resets to the right. So let's go into constants.h then, and we need to set up some constants now that let us obviously set things up, the clouds and trees and things up inside the game. So we're going to need some z indexes in here first of all, so everything's positioned. So I want a z index tree here, which is going to have a value of 50 because it needs to be in front of the floor. And then we're going to have z index mount, and we're going to have z index cloud. And for the mountain, then we're going to have 30 because we want that behind the floor. And then for the clouds, we're actually going to have two. So we'll have a cloud slow and a cloud fast, because we want to give a bit of an appearance of depth. So some of the clouds will be smaller and move slower than some bigger, faster clouds. So slow then can have 10 and fast can have a 20. That should keep everything still behind the robin and also positioned correctly here. A bit further down, I'm just going to make some space here at the bottom of the file. I also want to set up some speeds here as well. So the first thing I'm going to do then is define, and let's say k cloud speed, the small p, and the speed for the slow cloud, and we're going to set that to 7.0, but I want to multiply this by the y scale factor in case obviously it's an iPad. And then for the fast clouds, I want to have it by 25, and then we want the speeds for the mountain, which we'll set at 15.0, and last but not least the trees, and we'll set the tree speed at 32. And those values give something sort of reasonable. In fact, let's make the tree speed 30. Okay, and the last but not least, we need to set up some scales. And the reason for this is because we want I want to be able to have the flexibility to scale up or down the items on the screen if they don't look quite right. So we've got k cloud scale slow, and we'll set this to 0.4. I'm just going to do some brutal copying here. And for the fast, I'm going to set it to 0.8. Just call this fast. And then we want the tree scale, which can actually stay at 1.0 for now. And then last but not least, we need the mountain scale, and we'll set this to 0.8. Okay, so that's all of our constants added in, and we can now go into the intro scene and start setting things up into intro scene.m to set things up actually to run. So the first thing we need to do is for our flying objects on the screen, we need to store these, and we'll store these in an NS mutable array, and I'm going to call this flying objects, like so. And very importantly, of course, we need to initialize this array at the end of our init here. So I'm just going to say flying objects equals, and then NS mutable array alloc and init. Oops. To make sure everything's initialized. And now what we're going to do is write some functions to do the starting, the stopping of our objects, and then also the adding of our objects into the array. So to get on with the starting and the stopping here then, right at the bottom of the file, I'm going to write the start function. So we've got the start, and let's also then write the stop function, like so. And what we want to do just for now inside the start function, in fact I'll call this start game and call the next one stop game. And what we want to do then inside this start game is we want to be able to loop through all of the clouds inside our flying objects array and then start those, and in stop likewise stop. So at the top here I need to then import our cloud.h so we actually can reference it, and then here I'm going to say for and use this for in, and I want cloud pointer to cloud in the flying objects, and here I just want to say cloud and start, which starts the scrolling off, and then in this one here then I'm going to call cloud stop, like so. And now what I can do is call the start game and stop game in the relevant position. So here I'm going to call the start game. Now I'll clean up the logic later on in the application. I'm just going through this a little bit quickly because the video is dragging on, but I want to get everything done in this video for the scrolling objects. But really all this stuff here should obviously go inside the start game, but for now I'll just leave this here. And inside the game over here I'm going to call self and stop game, like so. So this will start and stop our objects, and all we need to do now is actually add our objects. So to think about how we're actually going to add our objects, well, we're going to add them at some fixed predefined positions. The problem is, of course, the positions change depending on the screen type, iPhone 5, 4 or iPad. So I'm going to make a little utility function inside this class here. It's something you might actually put in a library that if you're doing a lot of games and stuff. But it's going to return a CG point, and I'm going to call this scaled position from X, so it gives us an X scale position for a scale position for a certain X. In fact, no, let's not do it. Let's just call scaled position, and it's going to give us taking a CG point and then the position, like so. And we're going to scale this position, like I said, according to the screen we have. The first thing we need is the screen size, and I believe inside the init we already have a line which gets us our screen size, like so. And now what we can do then is we can return CCP, and what we want to say is then we want to say our position dot x multiplied by then, and we want screen size dot width divided by 480, which is our base width for all of our graphics and everything, and then we want our position dot y multiplied by then our screen size dot height divided by 320, which is obviously our base height. And that will, for any position now that we give, scale that position according to whichever screen we have. So now that we've got the scaling of the positions, we can write the function out where we want to actually add our cloud. So I'm going to call it add cloud with name, because we've got different files, remember, so we've got tree, mountain or cloud, which means we need an NS string and the name, and we'll say and position, and then this is a CG point and the position, and Z index, and that's an integer, and Z index, and then we want and scale, and we have our float of the scale that we want, and last but not least we want the speed. We'll say float and the speed. So this now allows us to add our cloud with all of these arguments going in here, except this should be obviously written like this. So the first thing we need to do then again is get the screen size here for the initialization, and now we can initialize our cloud. So we'll say our C cloud, cloud, can't spell, is equal then, and we say C cloud, and then it's obviously sprite with image named, sprite with image named, so it's the name that we have here. The next thing you want to do is important to do this next is set the scale already, so that everything is scaled before we start doing any positioning or anything like that. So set the scale like so, which was sent in as an argument. And the next thing we need to do then is set the position of our cloud. So and set position, and this position is set then to the position that was sent in as an argument. And the thing is with this position, I've just realized, is I need actually to use the scaled position function. Scale position from the position, so that's setting the position scaled according to the screen using this function. And now what we can do is we can initialize our cloud. So I want to call cloud and then initialize with speed. So and the width is the screen size dot width, like so. So that sets up the initialization. Now we can add our cloud to our screen itself with a Z index of the Z index. And last but not least, our flying objects can have our cloud added as an object. So that's quite a lot of code in there, and the video is dragging on a bit, I know, but we're very nearly there. There's just one more little function to write. So this function then is what we're going to use to add a cloud. And now what we'll do is we'll make another function simply called add all clouds, where we're going to call the above function one by one with some parameters that I've obviously already determined. And I've got those, I'm just finding them to the left hand side here, which you can't see off screen, just so that I can see everything. Okay, good. So the first thing we're going to do is self and add cloud with name. And the first name is cloud.png. Then we'll be doing mount.png and tree.png, and position, and the first position is CCP, and 350 and 305. And what I'll do now actually is I'll just fill out this one with the K Z index cloud slow, and the scale is K cloud scale slow, and the speed is K cloud speed slow. Now I've added this function in like this. It's going to be boring now for me to type the rest out. So what I'll do is I'm just going to cut this bit out of the video and add these all in by hand, and then you'll be back in the video with everything added in. You can just paste in the code from the download. Okay, so I've just built, everything's added in. These are the rest of the parameters that we added in. I've noticed I've called things K cloud speed mountain and cloud speed tree. It should be without the cloud, but it doesn't really matter. It's still pretty clear what it is. So now we've got the add all clouds function written, we can actually call this function then at the beginning of our initialization, importantly after we've initialized obviously this array. So we can say self and add all clouds, and I'll just hit build to check that it builds. And now just to double check, when we touch the robin now to start, we'll call start game, and this will then call start on all of our clouds. And then when the robin dies, so we've got game over, then we'll call stop game, which will call stop on all of our clouds or flying objects. So let's just give that a go at running it. Let's go to the normal iPad for now and just run. And you can see that the application started with some clouds and the mountains and the trees, and if I just start the robin off, you can see now that everything's scrolling along the screen and making it look as if the robin is flying. And if I let the robin die, then he resets the middle and everything stops where it is and then continues as you were when I start the game again. Good, so let's just run that very quickly then on the iPhone 3.5 inch just to see what that looks like. That looks pretty similar to the iPad despite the aspect ratio being different. Good, and everything should stop. And last but not least, let's just have a look at the iPhone 5. Check that we're not seeing any kind of strange speeds there or anything. And good, everything looks relatively normal and good here despite the different aspect ratio as well. Okay then, so it's a bit of a longer video, 25 minutes or so, and I'm sorry about that. Usually I like to keep them around 10, as you know, but we've made quite a bit of progress in this video. We've managed to write quite a good bit of code, and we have the ability now to add scrolling objects, and importantly we have this cloud class now, which we can probably, I hope, subclass in some kind of way to be able to make our tubes, and then we can look at actually the gameplay, the tube collision, scoring and everything like that. So thanks very much for watching. Comments, questions, criticisms welcome as always on YouTube.